Have you guys gone through the PR? And it's a simple one, but kind of interesting in like wallet level. So anything interesting? Okay, thanks. So anything interesting you guys observed during the PR that you want to mention before we jump in on the questions? And can you confirm if you can see my screen?
Oh, yes, you can
Yeah, I
see.
can see.
Okay, cool. So let's get started then. First question always starts with like this concept ACK, approach ACK, but it's already a merged peer, so I guess it doesn't make much sense. But anybody want to summarize what this peer does? Anyone just give a short, basic understanding of like what it's trying to do and why it did what it did. Okay, so basically, this is a PR that adds a new RPC into the wallet, which is send all. Previously, there was some issues with the way you can like sweep and wallet, like capture all the UTXOs and send it to one single address. So this adds a specific dedicated RPC to do that. That's what the PR is all about. And the description basically provides us a reasoning behind why this is the case and why they had to do it. Basically, the reason has to do with the complexities of coin selections, and then there were some behavioral changes when they introduced effective value for an UTXO. Before we jump into the second question, like the question is like when will you use a sendall and when will you use SFFA? SFFA means subtract fee from amount or subtract fee from output. It's a way of saying like while creating a transaction, take this output index and reduce all the fee from this guy. So that guy, whoever output was that, ends up paying all the fee. And there are certain situations and cases where you wanna do that. But before we jump into it, can anybody explain what is an effective value and why it was introduced and why it caused the problem? So where were we? We were on like, so we were basically discussing on the idea of the of this PR. We gave a description, and then the question was like, what is an effective value and why it is used and what it caused the problem. Can anybody take a stab? Yeah, basically, so basically it's like discounting the amount of UTXO with the amount of fee that is needed to spend that UTXO. So every UTXO, when at the time of spending, will require some input. That input will have some size, and that size has to pay for its fee. So it was included to make the coin selection algorithm simpler. So the coin selection target algorithm isn't dynamic anymore. Now every UTXO that you're selecting is also accounting for its own fee. But it also broke the behavior where previously when we could do SFFA with like fund raw transaction and uh, take all the put the input put the balance as the input amount and then mark an output as like this output pays for the fee, and that used to be the one single output of the transaction, and with that we used to sweep the wallet. But now the problem is like because of effective values, while creating that transaction, if we mention that fee rate will be like fee rate to be quite high, so there are inputs that gets rejected because of the effective value selection. So some input become dust, and then when we are putting the get balance and giving that as the target input to match, then it says like insufficient fees, insufficient amount. The wallet does not have enough UTXO because we were trying to match the get balance amount, while after removing the dust UTXOs by effective value calculation, the total available balance is much lower, but get balance doesn't see that. So because of that, so they were like planning on like creating some ways to get balance to either see in effective value or some ways to say like we don't care about effective values, just give us all the UTXOs. So in the end, they kind of decided on creating another RPC call dedicated just for that use case of sweeping. So that basically is this PR, and this PR basically it's a quite elaborate PR. It touches a lot many part of the code base. So if we see the def, it kind of like touches on the wallet RPC part. So it gives you an example of how a new wallet RPC gets added or any RPC call gets added, And then it has functional testing test. This one basically send all, basically this entire test is asserting all the behavior that send all needs to assert. So we'll go and talk about the test later. So that's basically an overview. And so then it lands us to the second question, like when would you use an send all and when would you use an SFFA? That's a good question, but you can have this kind of situation in normal wallet usage also, where you have a bunch of UTXOs, which is very small amount. So it also depends on the coin selection algorithm the wallet is using. So if the wallet tends to create lot of small outputs, change outputs, then after years of usage, you might have a situations where you are sitting with lot of UTXOs, but they are so small that at that fee rate, it all become dust. Now, the assumption of like rejecting this effective, negative effective value UTXOs is like, if you use them, you are gonna end up with a lower balance. It is assumed that the wallet user never want to have a lower balance. So that's why you kind of reject them. But there are ways to, I think, like select all of them. For example, like send all by default, I think selects all of them. And there is an flag. I have the help over here. So this is the help doc of send all, and there is a flag that basically says send max. This guy send max, whether true or false. When true, only use UTXOs that can pay for their own fees to maximize the output amount. When false, which is default, no UTXO is left behind, and send max is incompatible with providing specific inputs. Right. So this basically says like in most of the cases it will clear everything, but that will actually you'll end up having lower balance in your final consolidation output. If you use send max, you will lose UTXOs, but you will actually end up having higher balance, and that's kind of counterintuitive. Any other question at this point? Okay, cool. And so, anybody have a cool use case of SFFA, like when we might want to use like subtract fee from amount, or anybody have used it in wild for certain cases?
I haven't used it, but I imagine it's like when you want to send bitcoins via the wallet, you use it like specific amounts. You use
Right.
this. Yeah.
Right. Yeah. So on one of the points that came up in the IRC chat on this topic is like with SFFA, you are kind of like allotting a budget and saying like this is the budget of the output, and this is the total amount, and you have to subtract the fees from that amount, and you don't specifically care about selecting UTXOs or which UTXOs are selected. You don't want to like figure that out. You want that to be automatically handled depending on the output amount. So what SFFA was used with mostly fund raw transaction, this guy. So you will create a fund raw transaction where the output slots will be picked up, their amounts will be there, and you will mark like this guy pays for the fee. Or if you don't mark it, they will probably distribute the fee equally among all the outputs. Then it will do coin selection and select the UTXOs. With send all, you are like saying, I don't care about my budget. I don't have any specific requirement to send to anybody. I just want to send to one person, and I want to send everything. And here you also don't care about UTXOs, but there is no coin selection. This is interesting because in send all, you just either can send the entire set of UTXOs or the entire set of economic UTXOs, or there is an option like in the help talk, if we can see, there is an option to specify inputs. So you can specify a set of inputs and it will only spend those inputs. So this is like two different kind of like behavioral use cases you might want to use the transaction creation for. So kind of obscured, but in general, I think like the basic usage will be sweeping all the inputs from one wallet to another. And SFFA with fund raw transaction will be mostly used like for distinct kind of payment. Like I want to pay 10 parties, five of them gonna share the fees, and five of them are like vendors, and they will receive a set amount of budget. So that's where that can come in.
I had a question here, Raj.
Yes.
So when like why would anyone use the basic option where you choose all the UTXOs?
Or
Because
when in that only the case when you wanna sweep the wallet, like you wanna transfer one wallet, the entire wallet into another seed or something.
I mean, I'm just like thinking about the use case for that. Like you'll usually end up with less balance ultimately if you use that option, right? As
Or
opposed to
what are other, there are other ways to sweep the wallet like without creating transactions, but no, just I'm trying to understand what you're suggesting. But yeah, definitely you will end up with lower balance. You will end up paying the fee amount minus the fee, and that will be inside one UTXO. But sometimes like people use this, even exchanges use this because they use this thing to consolidate an entire wallet. So they will have like different wallets for like different use cases, and then there will be some wallet that will end up like having a lot of dust, and then you just want to consolidate the entire dust in one swift transaction. So send all is basically a swift transaction over the wallet, and for whatever reason you might want to create a swift transaction, you will use send all.
I see. Okay.
Yeah, and for personal use that can be like, okay, now you wanna you have been like trying around or playing around with a wallet, you have a bunch of UTX, so now you want to sweep all of it into your hardware wallet back again. So then you will use a sweep. Exchanges use it to consolidation. SFFA is not a good use case for consolidation. SFFA is like more targeted use. Consolidation is like a lot of inputs and only few outputs. SFFA can be like few inputs and a lot of different outputs, dividing the balance in different ways.
Right, right. Yeah.
But I think like it can, the way this RPC is structured, it can do both. So you can have a list of inputs, and you can you can have a format like this. So if you look at this RPC call at the end, so it's asking for recipient is this guy with this much balance and this guy with no balance at a fee rate of this. So what this will do is like create all the transaction consuming all your UTXOs, all your unspent UTXOs. Give this guy 0.25. Do not subtract fee from this guy.
Hmm.
Whatever is remaining after the balance and the fees, give that to this guy.
Yeah.
So in this way, you can like configure it to do various different kind of use cases. So this is kind of cool, and send all, and there are a lot of nuances about the ways these flags can be used. We will talk about one of the nuance in some few questions, but that is also something interesting. Is like you can craft a very specific kind of things with not the default all UTXO. You can like even select a set of UTXOs, and this gives a very structured way of like creating transaction, which is kind of cool. And some wallet might want to use that, and without like writing their own logic, they can just directly use this RPC call with the right flags, and they should be able to do it. Okay, so that's about SFFA, and moving on. Any other question at this point?
Raj, normally when I send a transaction, it's SFFA, right? Uh,
Not generally, because most of the wallet actually doesn't give you this option. So that was one other like discussion point they also talked in the PR thread, is like this SFFA is like something that core does, and the core UI gives you an option.
okay,
Theoretically you can do that, but most consumer wallet doesn't allow you to do it. I mean, they don't have the UI basically.
okay,
So most of the time you are not specifying fees. What you are doing is like you are specifying a recipient. The recipient is, you are basically simulating this case most of the time in wallet. Last one, this is your pay, like the payee, the recipient gets 0.25 Bitcoin, and this is basically your change address, right? And the change address like is, this transaction will be then constructed is like, what is the minimum amount of input that you need to select in order to cover 25? If the input selected is more than 25, you get change in this. If it's not, you get a changeless transaction. So most of the time we don't think we can do like SFFA in regular Bitcoin wallets, but it would be cool if some wallets allow. I don't know if anybody does.
Also, like these wallets, do they implement the coin selection algorithm by Bitcoin Core? Or
Depend on the wallet's code. Most of the wallet does. Um, so this coin selection is again another involved topic, and like core does it in certain ways, other wallet does it in certain ways, and kind of like every wallet has their own preference and like own engineering of like how they do their coin selection thing. But nowadays many wallets are trying to leverage the coin selection code that is there in Bitcoin code, the BNB and the knapsack solver, and trying to create the same strategy that core does. And but yeah, like then it's also very much customizable, like different wallet can have like combination of different strategies. BDK does it in certain ways, and it allows people to craft their own strategies. Like you can say like let's do knapsack first, then do BNB first, and then do like a single random draw, and then fall back to FIFO mode or like other things. No, but nobody has their own coin selection algorithm. Coin selection algorithms are very limited. Like there are only 3 4 standard coin selection algorithms, and the advanced ones are like knapsack solvers and BNB, branch and bound. And beyond like before that, knapsack and branch and bound and coin selection was like very ghetto way. Like find out a set that matches this target, and whatever that set is, there is no optimization, either randomly pick from the UTXO until you hit the target, or like create your own list and sort from there. It was like very hands on, and different wallet used to do differently, and code used to do differently, electrum used to do differently. Now it's like kind of like converging towards certain set of algorithm, and there is a fallback sequence: try this or this or this or this, and eventually you will end up with a solution. Okay.
What's economic UTXO? You mentioned it.
Oh, so economic UTXO is UTXOs with not negative effective value. So which was encoded value is higher than the effective value of the, or the effective value is not negative. Basically, a positive effective value UTXO is a economical UTXO. A non-economical means like it's gonna cost you more to spend that UTXO than the value that you will get by spending that UTXO. So it's not economical for you to even try to spend it.
Oh, makes sense.
Internally inside the code, obviously there is a map of UTXOs out there, and you can like write it out, but I don't know if that part is like exposed in some RPC in that way, so that like yeah, but internally you can find it. Like there is a so there are I'll not try to find it because I'll get lost in the code, uh, but there are part of the code where you can find the wallet's unspent UTXOs, and before the coin selection, it goes through a filter which filters out all the uneconomical UTXOs, and only the economical one gets inside the coin selector. So while using the wallet to create a transaction, it will not actually like see the uneconomic UTXOs, and that was the reason behind the problem, like why fund raw transaction broke after having effective value, because people were using get balance, and get balance is showing you all the balance, and while creating the wallet transaction, wallet is not seeing the uneconomic UTX and say like, there is not enough balance, so I cannot create this transaction. So that was the problem that inspired this send all RPC dedicated.
for let's say I have an economical like positive effective value UTXO, but
Mhm.
I'm not certain like after a year it will be positive or not. It might be negative. So like,
Right.
is there something Wallet do with this? Like, do they watch over the transaction fees or something?
Generally, like the wallet never tries to like break UTXOs too finely. Like you resolve these issues by not having a lot of dust. If you're not having a lot of dust, then having negative effective value UTXOs is like almost very hard to do, unless you are doing some very typical or specific kind of like behavior. For example, getting a lot of payment and sending a lot of payment out, But normal use cases, the wallet will always try to like consolidate the UTXO, because that's one of the goal of the coin selections branch and bound, to consolidate the UTXO, not to break them finally. And most of the cases, branch and bound gets the solution. So you will almost not end up having a situations like that. But if you are an exchange and if you have certain behaviors that can create those kind of like lots of dust outputs, then you should be like periodically consolidating them and not leaving them for a long time in the UTXO set, because then you will end up having like paying more to consolidate those dust than the total value of the dust itself. Right.
So like it's we have to manually do this, right?
Yeah, basically, like you have to have some kind of system to manage your UTXO set. Depend at this level depends on what you mean by manually, because on those use cases, people will have code to do it, not like they will like
Yeah.
do RPC call in Bitcoin CLI to do it by hand. But there will be code to like continuously keep the switching transaction happening.
Thanks, Raj.
Okay, moving on. So the next one is like a comment suggests that this peer is potentially unsafe to have. And do you agree with this or not? Have anybody seen the comment? Yeah. So the one thing that like fund raw transaction was doing is like it was enforcing the total amount to be spent, because it was about a budget, right? You always decide the budget first and then create the transaction. But here there is no budget. It's like whatever you have gonna get swept all together. So yeah, that's a like dangerous situation. But one the observation over there was like, what if now a hacker who gets an RPC access to your Bitcoin wallet has one RPC call to sweep all your fund transaction, like all your UTXOs into the thing. But then again, like if the hacker gets into your Bitcoin CLI RPC, sendall doesn't make it any easier. It's anyway easy for him to like sweep all the funds in a transaction, right? So it doesn't like reduce the security in that sense. But it's yeah, it's a user can like screw itself and like fat finger and put it sweep a wrong wallet or something. Yeah, maybe some throwing in some warning like are you sure, like really are you sure you want to do this, something like that can be helpful. Or given a warning like in the GUI, like you are about to sweep all your UTXOs. So but yeah, I guess like people who will be using it is comfortable with that risk. And it also shows experimental in the help. I don't know why that there's like this call may be changed in future release. So probably there are some work going on improving this or in changing in some other ways. Anybody has any other ideas or thoughts that can like create problem with this RPC? Moving on. So I guess that's mostly of the problem about it. Otherwise, it doesn't seem to be a big issue. So okay, so the next one is like, why are sendmax and inputs exclusive option? So before that, like, what is sendmax? Can anybody explain sendmax? What does this do? It's in the flag. I'll also open up the help. So sendmax, we already talked about it a few moments ago. Sendmax pull. So basically, sendmax is, we talked about it and we answered it. So sendmax is like send the maximum possible value. So reject all the effective value. But now it is in exclusion with input. So if you specify inputs, you can't specify sendmax, or if you specify sendmax, you can't specify input. Why is that? But at the same time, couldn't you say like, here's a bunch of input, but send max of that input? Like I'm trying to say, like if this input contains uneconomic UTXOs, remove them.
So
Yeah.
it's just another iteration, like an additional option in the same thing, right? Like it's just changing the set. So right now it's just it'll do it across all the UTXOs,
Yes.
and you want to limit that as well.
Yeah. And so yeah, like I don't know, like it could be done. Like in my head it seems clear, but it could be
Yeah.
confusing in that sense, like inputs and send max. But if I think of send max is a mechanism of sending max possible of a given set, By default is the entire set of UTXOs of the wallet. But if I just set like this is my UTXO set and send max of that, the wallet should be able to like figure that out also. Like, okay, now some of are uneconomic in this set, so I will reject them. Could be done, but yeah, like the author went for like not having them on together because it could be confusing.
Do you think having this in its own specific RPC call would be worth it, or is it like a very obscure use case?
Send max?
Send max from this set.
I don't know. Like if it makes sense for another RPC, it totally makes sense for like these two flags to be on together, I guess. If you can like yeah, basically then the RPC will look basically this. You are setting a set of inputs and then you are saying send max of that.
Yeah.
But I think it's an interesting question, and there might be some kind of like possible improvement option also, but I don't know. There can be complications around the code while trying to interpret these two arguments together. Any other observation on this? Does anybody else thinks like it could be confusing to have send max and inputs together, and have any other rational or reasoning for why that could be the case?
Seems confusing to use both of them together for
Yeah.
me.
Yep. Okay. Moving on, why sendall restricted to spend only confirmed UTXOs? There are like many answers for it. So anybody want to pitch it? So sendall only selects confirmed UTXOs, not unconfirmed one. Why is that? Apart from that, it's kind of obvious that you don't want to spend unconfirmed UTXOs yet. But any other reason people can think of while having unconfirmed UTXOs can cause problem? I think one of the reason could be like if you're having unconfirmed UTXO, you have to also look ahead for replacements. So what if you choose a UTXO and that UTXO or the parent of that UTXO got replaced, right? And then you have to take that into account, and that will increase complexity. Whereas in confirmed UTXOs, you do not have the double spending problem. And RBF is like very tricky in the sense like if this transaction doesn't even signal for RBF, but one of the inputs of this transaction signals for RBF, then it's implicitly RBF. So even if you are not setting the transaction, the sweeping transaction as RBF, it's implicitly RBF because some of your unconfirmed UTXOs can be RBF and be replaced. That's why like they kind of like went ahead with not including the complexity of like even under managing unconfirmed UTXOs for this thing. So only the confirmed UTXOs. Well, the wallet actually uses unconfirmed UTXOs in certain cases while creating general transactions. For example, if the unconfirmed UTXO is created by your wallet only, like it's a self-payment, and or it's a payment created by your wallet and you have a change address and that change address isn't confirmed, is unconfirmed, then the wallet allows you to use that change address also. It's called the trusted unconfirmed. So it's unconfirmed, but it's kind of trusted because you know you created that transaction. So so it allows only those kind of unconfirmed, but other kind of unconfirmed it doesn't at the time of creating transaction. Any other comment and remark on confirmed unconfirmed? That was straightforward, I think. And yep. So the next one is like, why are there two ways of specifying recipients? Basically, I think what they're trying to mention is inside the help, you see like there are two ways of mentioning the recipient is like one by the amount and another by not the amount, but like no amount. The question is like, why? And I think the basic answer for that is like to use more, like allow a lot of more like custom and complex use cases, while like at the sweep transaction you can also pay a particular recipient. Anybody else have any thought on like why having like different kind of like this thing can add into other kind of use cases, and what kind of other use cases you can think of? Yeah, so that's what it will do. I think like if you put two addresses without amounts, the amount will get splitted between those two addresses, and the fees will also get splitted into those two addresses. So you can like customize it in that way. Yeah, kind of like pretty useful way of like creating transactions. And with the input flag set, you can almost create any kind of like custom transactions you want also with this. Yep. Anybody uses Bitcoin Code's RPC in their wallet management code? Karthik, like does Gala use it somewhere, or they do it in separately?
Yeah, we use I think list wallets and even load wallet, because I think it no longer loads by default, if I'm not wrong. But
Right.
I think those are the only two we use, because our on-chain part is from LND only.
Okay. Okay. So you just okay, load the Bitcoin wallet and then let LND manage that wallet and then query LND for wallet related.
Well, LND doesn't manage that wallet. It's just that you need to load wallet for like some functionality to be available.
But then how again you like fetch the transactions from those wallets?
We don't use that wallet at all.
Oh, okay.
Yeah.
Huh? Then why do you load that wallet?
I think there's
Sorry, I'm like just having like trying to understand it and having a non-contextual discussion. Yeah.
Yeah, I think it's because some functionality is not available if you don't load the wallet.
Okay.
Uh,
Oh, okay. Right. That makes sense. If you don't have a wallet, the wallet RPCs will be disabled. Is that what you're saying?
Possibly, yeah. I'm not sure which one, like what functionality is not available. I think it's that. But yeah, it's been some time since I touched that
Okay.
part. So
Okay. Cool. So that's basically the reason why we want to specify wallets. We like specify two ways of different ways of specifying recipients. We want to have like cool use cases where we can pay and sweep at the same time. And moving on to the next one, looking at the cleanup decorator in the trest, can you guess where the code base sendall may find use? Can you guess where in the code base send all may find use? So this question basically says like if we look into the test file that got added. So this is the send all behavioral test in the functional testing framework, and it has a Python decorator called cleanup. And what this cleanup does is basically get the balance. If the balance is more than 0, do a send all to a remainder target. It's basically an address, hard-coded address. Do a send all to that address so that the wallet basically clears up. And the question is like, where else in the code base can this be useful? So by the look of this code, it seems like this is useful for any cases where you create a wallet, do some transactions, test something, and just want to clear the wallet, right? It's just a cleanup code. So basically, everywhere you want to use cleanup of an wallet, the send all RPC itself becomes a very useful function that can be called and like clear the wallet in that way. Anybody has any other observations where they think like this kind of wallet cleanup can be useful? Yeah, basically this is just sending to one destination address, whatever this remainder target is, and this remainder target is set over here. Where the run test is that obviously like send all can be used, but this question was specifically where exactly inside the code we can use it. So yeah, this is like one example of like inside this wallet or anywhere you are using a wallet and writing functional test where you wanna clean the wallet after doing the test. Maybe like in the next try you wanna start with a fresh wallet, and without creating a new wallet, you can start fresh from that wallet and sweep the fund away. And anywhere you will be using that kind of cleaning process, this entire decorator basically becomes useful, this cleanup decorator. And the cleanup decorator is basically that action in just one go. Do the function, whatever the decorator is applying the function on top of, do the function and then do a sweep. So all these functions over here, like send all split. So this is doing a send all split. So splitting between different addresses. And after this functions, it just cleans up the wallet. So this is a cool way of like very conveniently cleaning up the wallet without like recreating new wallet every time. So that's mostly it about where I don't think like anywhere else you can use it. In unit test, you can't because you don't have a full wallet over there. And mostly inside functional test, I think it can be useful. And okay, and the last option is how are the fee estimation instruction up for interpretation? So this basically points to this function where it's saying interpret fee estimation instruction. And what it is trying to do is it's trying to say is like if you look into the help doc, there are three ways of like estimating the fee of this transaction. So either we can say like this is the confirmation target, I want confirmation in next 6 blocks with an estimation mode. I want to be very conservative, I want to be economical, or it can be unset also. Or we can say like this is the fee rate, direct fee rate that I want to use for this transaction. But that's not it. So this is like positional argument of this RPC. But then again, inside these options, the same field appears again. So confirmation target, estimate mode, and there is fee rate. There is fee rate. So there are like two places where we can specify the options, and I'm not exactly sure why. So anybody has any idea why this might be the case? I guess like it has been the case for all the RPCs, not only send all, but send, fund, raw transaction. I'm not sure, I have to confirm, but because of this, so all this function is doing like interpret estimation instruction is basically doing some sanity checking. It's saying like, is it set in option? Is confirmation and estimate, confirmation target and estimate mode set in options? At the same time, it's set in positional argument, then throw this error, pass confirmation target estimate mode either as argument or in options. So you cannot pass them together. Either you have to put in an option or into positional argument. Same thing for fee rate. Is it in option or positional argument? If it's both, then throw an error. And then lastly it does another sanity check, which is another edge case, which is saying like if confirmation target is there and estimate mode is null and estimate mode is unset, then also throw an error, because with confirmation target we need an estimate mode. It matters whether we want to we want to confirm in 6 block in a conservative way or in a very aggressive way, right? So these two kind of goes hand in hand together. So this checks like they both has to be provided. So this is why this interpretation is there. But I think like, I don't know, it feels to me it will be much more simpler if it was just in one space, like either in the positional argument or in the option field. But that can be a potential future PR improvement also. So, yep, I guess that's about it for all the questions on this topic. Anybody else have any other thoughts and questions that we can uh, churn over? We have 10 more minutes. I guess this is the one, right? So it adds with a release note, and this one is interesting. This is a table. If you haven't seen this table, you might want to take a look at it later on. This table is like a translation between all the arguments which are not exactly text or not exactly numbers, some other values, either JSON values or like strings or things like that. So every time you add a new RPC call, you have to like put things in this table for arguments of that RPC which are not integers. So this is one interesting table. And in the wallet send RPC, so in wallet RPC, so it adds a new function called sendall. So previously there was already an RPC called send. This adds a new function send all. And where exactly is the function? I think this one. Yeah. So you can go through the entire RPC code. This is the interpretation of it, and I think it adds later here. This is the entire RPC code that got added. So RPC code starts with the help doc, and after help doc, it includes a lambda, and that lambda basically includes the code. So I think it starts from here. Yeah, this is the lambda that starts with the RPC function that executes. So this is also interesting how it creates the transaction depending on all the flags and all. So this is an interesting part of the code that you can take a look on in understanding how a transaction gets created. And after that, another interesting part would be in wallet CPP, nothing happens much over here. Test runner got added with sendall.py. So sendall.py is the new test runner test code. So testrunner.py is the Python file that runs all the tests in sequence. And a new test got added. And we test it with both legacy wallet and descriptor wallets. And here the entire new test that got added. And this test is also useful. One thing I wanted to mention that occurred to me while going through this test is, so we were talking about these feeRate situations, right? So confirmation target, estimate mode, feeRate, and having them in both different location. And also there is a link between confirmation target and estimate mode. Apparently this behavior is not tested in the test functional test. So this can be an interesting PR to add a test for this behavior. What happens when different fee rates at different places are applied and whether the correct error is being thrown. And also having one question thing I wanted to try is like what happens when I put confirmation, estimate mode, and fee rate all together. So in that case, I am saying like this guy together will create a fee rate. I'm also specifying another fee rate. So which one does it choose at that time? Is that an error, or it should choose the highest of the two fee rate in that case, or it should give a error to the say like you can't put this together? It seems like this behavior is also not enforced in the C++ code because this interpretation does not check. Sorry, this is in spend.cpp here. Interpretation does not check whether the fee rate and confirmation target are all set together or not. So by theory, you can put confirmation target, estimate mode, and fee rate all together, and they will simultaneously exist, and there will be no error from this part of the code. So could be a behavior exercise to check like what happens when that situation is simulated.
So this use case is not being tested currently.
Not being tested currently, not in this file.
So then the PR in its current state will not be merged, right?
At the time, nobody. The PR is already merged. It's a very old PR, and at the time, nobody apparently pointed out. So one thing we might want to check is what's the situation in master for this test, and does master contains any of them? Sendall with max conf, minimum conf, watch only specific inputs. No, it doesn't seem like there has been any work done on this part of the code after this PR has been merged. So probably nobody made that observation. And but yeah, I don't see any reason why we cannot test it. And also, like it would be interesting to pin the behavior of what happens when you put all the flags together, and maybe that can be an interesting PR also. Okay, guys. So I think if there is no more question, then so even I'm not too much expert on that, but my guess is like what they do is so there is this API in Bitcoin CLI. Or something with fee estimation, I guess. Let me check. Estimate smart fee with confirmation target, and this guy, we go with the help of this guy. Estimate the approximate fee per kilobyte needed for transaction to begin confirmation in the confirmation target. So what it does is basically it creates its own statistics internally, and it looks at the mempool, current mempool, and last few blocks, and then it tries to project ahead, like within next 6 blocks, to get into what will be the fee rate for that. And there is an API that anybody can directly use on any running Bitcoin mainnet node. And even like public nodes allows to do that. I think Electrum server also allows you to do that. So in that way, like you can estimate a fee. But the statistics of like how they do it internally is kind of like probably a bit involved, and I don't know exactly where in the code it is, but could be a good thing to explore upon. And maybe we can do a review club on that topic also later on. Yeah, there will be some peer related to that. That will be one interesting one. So another question I had for the participants here, like, feel free to suggest reviews, suggest PR topics to review, or like suggest like PR domains, like whether you wanna do the P2P next, or an RPC next, or a wallet next. That will be cool. We can keep rotating around so we don't get bored with one single kind of topic. Okay, so we can end our session for today. What say maybe next week we do a P2P one, will be fun. Some node behaviors and P2P logics. Thank you, man. Thank you for joining, and guys, see you next time. Bye bye.